Hi, today we're looking at Functional Skills Maths Level 1. We've got the NCFE exam board. This is past paper P001435 and we're going to start with the non-calculator section. Activity 1, litter picking. 1A. Lisa reads an article about litter picking. She reads that last year over 560,000 people in the UK took part in litter picking. What is 560,000 in millions? So you'll see I've already put my commas in here to put the thousands in there. Now, what we want to be thinking is we've got 560,000. We want it in millions. Well, I know that if we had 1 million, that would be 1 and 6 zeros after it. So if we want to turn it into millions, we're going to need to divide it by 1 million. And dividing it, we're going to make it smaller. And we've got 6 zeros. So if we imagine we've got the decimal point at the end, we're going to move it 6 times. So 1, 2, 3, 4, 5, 6. And then place a 0 at the front. So we're going to have 0.56 million. Okay, 1B. 96,000 hours were spent litter picking last year in Lisa's area. Lisa works out that 96,000 hours is over 4,100 days. Is she correct? Okay, so 96,000. So 96,000. So we want to get that one down first of all. Well, what we can do, we can either try and turn the hours into days, or we can try and turn the days into hours and then do a comparison. Generally, it's easier to multiply than divide. Not always, but what I'm going to try and do is turn the days into hours. So if I've got 4,100 days, there's 24 hours in a day, so we would have 4,100 times 24 hours. Okay, so what we're going to want to do is multiply these together. Well, I'm going to ignore the zeros for now and just say, well, let's do 41 times 24. And we can put the zeros on afterwards. Well, we've got 1 times 4 is 4. 4 times 4, we've got 4, 8, 12, 16. Now we move on to the tens here, so we can put a 0 beneath. 1 times 2 is 2. 2 times 4, 4, 8. Then we add these together. 4 plus 0 is 4. 6 plus 2 is 8. 1 plus 8 is 9. But if you remember, we had 2 zeros here. So we put them at the end there. We need to put them at the end here. And then to work out where my comma goes, we count back 1, 2, 3. So we've got 98,400. Okay, well, 96,000 is less than that. So Lisa works out 96,000 is over 4,100 days. Well, no, it's less than 4,100 days because that relates to this. So the answer is no. So it might help to just show that both of these are now in hours. Okay, 1C. Lisa joins a litter picking team. She starts walking north along a path and then turns clockwise to face southeast. What angle in degrees has she turned through? So let's draw a compass. She's walking north. Well, we have north at the top, south at the bottom, and we go never eat shredded wheat. Okay, so she's walking north, she's starting up here, and turns clockwise, so that's this way round, to face southeast. Well, southeast will be halfway between the two, it'll be southeast. So she's going from this way round to here. Now, you can think of that if I draw this as an angle like this, we've got a right angle here, and then we've got this angle here, which is half of a right angle. So hopefully you'll all know that a right angle is 90 degrees. And if we want half of 90 degrees, we're going to do 90 divided by 2. So 2 goes into 9, 2, 4, 6, 8, 4 times, and 1 carried over, or 1 remainder. 2 goes into 10, 2, 4, 6, 8, 10. That's 5 times. So we've got 90 in the angle at the top. Then we've got 45 degrees, that bit below. Add these together. 0 plus 5 is 5. 9 plus 4 is 13. So we've got a total of 135 degrees. Okay. 1 part D. Lisa joins her team at the collection point. These are the weights of litter each person collected this week. So you've got Lisa collected 8.5 kilograms, Carl collected 9.08, and so on. The mean weight this week is 0.5 kilograms lower than the mean weight last week. Work out the mean weight for last week. Okay, so what we're going to want to do is work out the mean for this week and then use this to adjust it. So the mean is calculated by finding the total of the values and then dividing by the frequency, or how many we've got. Okay, so for the total, well, it's going to be 8.5, 9.08, 9.7, and 8.12. Okay, so let's add these all up. Well, I've got some that are different lengths, so I'm going to put zeros in here to make it easier to see. So we've got 0 plus 8 plus 0 plus 2, so we've got 10. Carry the 1. 5 plus 0 plus 7 is 12, plus 1 is 13, plus another 1, 14. Bring down the decimal point. 8 plus 9 is 17, plus another 9 is 26, plus 8 is 34, plus 1 is 35. So a little bit squashed there, but we've got 35.40 kilograms. Okay, so that's our total, 35.4. And we're going to divide that by the frequency, which is how many? So we've got 1, 2, 3, 4. So let's do that using the bus stop method. Well, 4 doesn't go into 3, so we try 4 into 35. Well, we've got 4, 8, 12, 16, 20, 24, 28, 32, 36 would be too many, so we're going to stop at 32, so that's 8 times. And then 33, 34, 35, so that's remainder 3. So then we say 4 into 34. Well, if you remember, we already saw that 8 went into 32 8 times, and then 33, 34, that's remainder 2. So I'm going to need to put a 0, so I've got somewhere to put my remainder. Now we say 4 into 20, goes 4, 8, 12, 16, 20, 5 times. So we've got a mean of 8.85. And they said the mean this week, which is what we've just worked out, is 0.15 lower than the mean last week. So what we need to do is to add that 0.15 onto the 8.85 we've just worked out. So we've got 5 plus 5 is 10, 8 plus 1 is 9, plus another 1 is 10. Bring the decimal point down, 8 plus 1 is 9. So we've got exactly, we can put this in the answer box, 9 kilograms. And we don't need to put the zeros because they're after the decimal point. Okay, 1E. The table shows the weights of litter each person collected. So I think, is this the same table we had last time? Yes, it is. Write the weights in order of size, starting with the smallest. So sometimes it helps to write one above the other. Because we've only got 4 here, I think this should be fairly straightforward. 2 begin with 8, 2 begin with 9. So the 8s are going to be the smaller ones. We've got 8.5, so that's 5/10. 8.1, that's only 1/10. Doesn't matter the fact there's the 2. This is always going to be bigger than this one. You can think of this as being 8.50. Then it might be easy to see that this is bigger. Okay, so Mia's going to be first. 8.12 kilograms. Then 8.5 kilograms. So between these two, well, we've got 9.08. Or again, if you think of that as 9.70, you can see that one's bigger. So 9.08 kilograms. And finally, the 9.7 kilograms. Okay, 1F. The litter is divided into 3 categories. The table shows the percentage of the total litter that is in each category. So we've got 1 million aluminium cans, 60%, plastic bottles, 15%, and general waste is 25%. And of course that gives a total of 100%. Okay, now it says complete the pie chart on the next page to represent this data. So with a pie chart, we need to work everything as if the total is 360. Okay, so we've got to think, how can we turn these from being out of 100 to being out of 360? And there's a few different ways of doing it. What I'm going to do is we can say, well, there's a few different ways to do it. I'm going to look at, well, how do we get from 100 up to 360? So I'd say, well, let's do 360 divided by 100. So we can cancel a 0 straight away. And 36 divided by 10, when you move the decimal point, so it's going to become 3.6. So we're multiplying by 3.6. So we're going to want to multiply each of these by 3.6. Okay, so 60 times 3.6. Well, what I'll do for this one, we'll do it over here, is I'm going to do 6 times 36. So I'm ignoring a 0, I'm ignoring the decimal point, I'll put them in afterwards. So we start with 6 times 6, 6, 12, 18, 24, 30, 36. And 3 times 6, 6, 12, 18, plus a 3, 19, 20, 21. So we've got 216. Okay, remember we said we had a decimal point. The 3.6, we need to move the decimal point in 1. But also, it should have been 60, so we're going to move the decimal point back out. So they cancel each other out, really. So this is going to be 216 degrees. Okay, now for the plastic bottles, we've got 15 times 3.6. We can do that differently, I think. So I'm going to say 15 times 3.6. Well, I'm going to split that up. I'm going to say that's 10 times 3.6 plus 5 times 3.6. The reason I've done that is because 10 times 3.6, we're just going to move the decimal point, so that's going to be 36. And 5 times 3.6, well, 5 is half of 10. So basically, we want half of 36. So 2 goes into 3, 1, remainder 1. 2 goes into 16, 2, 4, 6, 8, 10, 12, 14, 16. That's 8 times. So we've got 36 plus 18. So 36 plus 18. 6 and 8 is 14. 3 plus 1 is 4, plus 1 is 5. So we've got 54 degrees. Now we can do something similar for 25 times 3.6. Or we could say, well, we know the total is 360, so we work out the difference. I'm going to do something even, well, I think easier than that, is if you can spot it. 25% is a quarter. Okay, you should know 0.25 is a decimal, 25% a quarter. So we want a quarter of 360. Well, if you know your circles or your compass directions, if that's 360, then each of these is a right angle, which is 90 degrees. Okay, so this one is going to be 90 degrees. And I've not lined them up. Would have been nicer if I did. Let's move that over here. You can add them up. They're all going to, well, 6 plus 4 is 10. 0 carry the 1. 1 plus 5 plus 9 is 15. Plus 1 is 16. 6 carry the 1. And 2 plus 1 is 3. So that all ties up. We've done the numbers bit. Now we need to draw the actual pie chart. Okay, so we're going to need to turn this over here. Categories of litter. Right, so if you remember, for aluminium, we had 216 degrees. Now, I'm going to need my protractor for this, but my protractor doesn't go up to 216, it only goes up to 180. So instead, I'm going to do the other categories first. This nice one here, we know that general waste, we said was 90 degrees. So if I line this up here, so I've got that in the centre. My line's going up because I'm going to measure this way round. Here's 0, 10, 20, all the way round to 90 degrees here. Okay, so we should have a right angle. And that bit with 90 degrees, that was general waste. Okay, then we had plastic bottles with 54 degrees. So now I'm doing this upside down. You can turn your whole page upside down if you want, if it makes it easier. So here's 0. We're using the blue numbers. 0, 10, 20, 30, 40, 50, 54. Well, 50 lines up with 130. So 51, 52, 53, 54 would be there. So this is going to be our plastic bottles. So everything else is our aluminium cans. Okay. Yeah. And there's our pie chart. So 1G. The table shows information about the litter collected over 2 weeks. So we've got week 1, the total weight was 340 kilograms, and 55% of that was aluminium cans. In week 2, the total weight was 380 kilograms, and the percent of that, the percentage of the weight that was aluminium cans, is 50%. The supervisor thinks that the weight of aluminium cans collected in week 2 was greater than the weight of aluminium cans collected in week 1. Is she correct? Right, so let's do them separately. Let's do week 1 here. So we want 55% of 340. Okay, so again, different ways of doing it. Some people would like to write 55 over 100 times 340. I'm going to do it differently. I'm going to say, well, let's do 50% first of all, because 50% would be half. So I'm going to treat this as 50% plus 5%. Okay. So 50% would be 340 divided by 2. 2 goes into 3, 1, remainder 1. 2 goes into 14, 2, 4, 6, 8, 10, 12, 14, that's 7 times. 2 goes into 0, 0 times. So we've got 170. 5%, what you might notice is that 5 is a tenth of 50%. In other words, it just has the 0 taken off the end. So that means we can do the same. 5% is going to be 17. So we've got 170 plus 17. 0 plus 7 is 7. 7 plus 1 is 8. 1 plus nothing is 1. So we've got 187 kilograms, which is aluminium cans for week 1. Right, if we do week 2 over here. Okay, so this one is more straightforward because it's just 50% of 380. So 380 divided by 2. 2 goes into 3, 1 remainder 1. 2 goes into 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's 9 times. And 2 goes into 0, 0 times. So we've got 187 grams versus 187 kilograms versus 190 kilograms. This is bigger. So the supervisor thinks the weight collected in week 2 was greater than that collected in week 1. Is she correct? Yes, she is. Because this number is larger than this one. Okay, and now we're on to the calculator section. Activity 2, the pet shop. Petra owns a pet shop. She wants to order 24 kilograms of cat food. The cat food is sold in boxes. One box holds 48 pouches. Each pouch holds 80 grams of cat food. Petra thinks she should order 5 boxes. Is she correct? Right, loads of information, but essentially we've got 2 things we need to work with. One is how much food she needs, and the other one is how much food she's got, and then we can compare them. So she wants to order 24 kilograms of cat food. Well, I know that there's 1,000 grams in 1 kilogram, and this is all working in grams, so I'm going to do everything in grams. So if we've got 1,000 grams as a kilogram, well, 24 kilograms is going to be 24 times 1,000, which is 24,000 grams. Okay, now we look at how much they've actually got. One box holds 48 pouches. Each pouch holds 80 grams, so we're going to have 48 lots of 80. And she thinks she should order 5 boxes. So all of this multiplied by 5. So we can use our calculator now. Multiply it all together and we get 19,200 grams. Okay. She needs this amount. She's got this amount. So is she correct? No. And we can put, because 19,200 is less than 24,000. Another way that you could do this would be to say, well, let's work out how many boxes she needs. So we could do the 48 times the 80. Which tells you how much she needs. 3,840. Put that in the memory. And we could say, well, if you've got 24,000, divide that by the amount you've got in one box, and would need 6.25 boxes or 7 boxes. So 5 definitely isn't going to be enough. So either of those methods would be absolutely fine. Okay, part 2b. Petra orders a box of rubber dog bones. The bones are different colours. The probability that Petra takes a red bone out of the box first is 3/5. Mark this probability on the probability scale. Well, here's our probability scale. So it's marked from 0 to 1. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. Well, this is out of fifths. So what we can do is if we make it out into tenths instead, that will help us. Well, 5 goes into 10 twice, so we're doubling that. So we can do the same with a 3. So if we double the 3, 3 times 2, we get 6. So we're getting that 3/5 is the same as 6/10, and the reason that helps is because then we can just say 1, 2, 3, 4, 5, 6, and we can mark it there. And 2C. Petra orders a box of toy animals for pets. The probability that Petra takes a toy dog out of the box first is 3/10. The probability that she takes a toy monkey out of the box first is 7/20. Which is Petra more likely to take out of the box first? A toy dog or a toy monkey? So we've got dog is 3/10. Monkey 7/20. Well, we can just work it out, turn it into a decimal. 3 divided by 10. Actually, I'm going to turn it into a percentage, so we're going to do that and then multiply by 100. Is 30%, and 7 divided by 20 times 100 to make it percent as well is 35%. So the more likely one is going to be the bigger probability, which is the 35. So it's going to be monkey. You could have just done these as decimals, but then you're comparing 0.3 with 0.35, and I think it's just easier to have them as percentages. Okay, 2D. Petra wants to buy a new tank for tropical fish. She finds these offers. Offer 1 was £950, now 25% off this price. And offer 2 was £950, now only £720. How much cheaper is offer 1 than offer 2? Right, so we want to work out 25% of this. So 25 out of 100 times 950. This is how much they're saving. 100 times 950, saving 237.5 or pounds 50, and then we want to take that off the original, so we're then going to do 950 minus 237 pounds 50. Well, what I can do is I can put that in my memory. Make sure you've cleared the memory from before. So we can say 950 minus that amount gives us £712.50, which is less than 720. Now they want to know how much cheaper, so we want 720 minus £712.50, which gives us 7.5 or £7.50. Okay, 2E. The tank is a cuboid with these internal dimensions. So we've got 180 centimetres across, 46 centimetres deep, and 54 centimetres high. Petra will fill the tank, well sorry, when I said depth, maybe I should have called that width, because with a tank we think of depth that way. It doesn't really matter what you call each of these, as long as you recognise these are the 3 different dimensions. Petra will fill the tank with water to a height of 50 centimetres. Okay, so actually, although that's 54 centimetres, we're only going to go up to 50 centimetres. She uses this rule to work out the number of small fish she can put in the tank. 1 small fish for every 5 litres of water. Work out the maximum number of small fish Petra can put in the tank. Use 1 litre equals 1,000 centimetres cubed, and you must show we are working. Okay, so what we're going to do first is we're going to work out the volume, but it's not the volume of the tank, it's the volume of the water, so how much water we've got in there. That could catch you out. So the volume is the length times the width times the height, which in this case is 180 centimetres, times 46 centimetres, times, remember I said the depth is the depth of the water, so it's the 50. So if we multiply these together, 180 times 46 times 50, we get 414,000 centimetres cubed. Now remember they told us that 1 litre is 1,000 centimetres cubed, so we're going to need to divide that by 1,000 to get the number of litres. So we've got 414 litres. Well, if you can have 1 fish for every 5 litres of water, we need to do 414 divided by 5. Which gives us 82.8 fish. But you can't really have 0.8 of a fish, so we're going to have to go with, right down the bottom, 82 fish. And that was for 5 marks. Okay, part 2F. Petra has a bird cage with a base in the shape of a pentagon. Draw a pentagon. So pentagon, 5-sided shape. 1, 2, 3, 4, 5. I've deliberately drawn it not a regular pentagon because they haven't said it's got to be regular. It didn't say sides need to be the same. Just a pentagon, 5-sided shape. Okay. Part 2G. The diagram shows the side elevation of a reptile tank. Which of these describes the type of angle marked A around here? Okay, well they've given us multiple choice. Let's do it by a process of elimination. Well, I know it's not a right angle because a right angle is when you've got something like that. Okay, so it's not that one. An acute angle. Well, an acute angle is smaller than a right angle, so that would be something like that. So maybe the inside would be acute, but not the outside. So we've got obtuse or reflex. Well, obtuse is going to be something like that. So it's bigger than a right angle, but smaller than a straight line, smaller than 180 degrees. So it's not obtuse, that would be that one. So it's going to have to be a reflex angle, which is sort of like the opposite of an obtuse angle, is the outside. Activity 3, fundraising. 3A. Ms. Patel is a college tutor. There are 630 students enrolled at her college. Ms. Patel teaches 20% of the students. 4/9 of the students she teaches are part-time students. The rest are full-time students. Ms. Patel thinks she teaches 15 more full-time students than part-time students. Is she correct? Show how you decide. Right, so they do like to give us lots of information, and we're going to work out how we can present this in a nice way. So we want to get rid of all of these numbers. So what I'm going to do is I'm going to turn this into a table, I think. And so what types of information? Well, we've got students, some that she teaches, some she doesn't teach, and some are part-time and some are full-time. So maybe let's draw a table. Okay, I'm just going to put a few lines in. You don't need to be 100% sure what you're doing to start with. You can work it out. So we're going to have, well, some are going to be part-time and some are going to be full-time, and some she teaches and some she doesn't teach. And so what I'll do is I'll put another couple of lines in now, because we're going to want to have some totals for these as well. Okay, there you go. Now we know that there are 630 students in total, so that's going to be down here. So this is a total, and this is another total. So this total will be for the rows, and these totals for the columns, but it's all going to add up to 630. She teaches 20% of the students. Okay, so teaches, so we want 20%, or 20 out of 100 of the students, which is 630. So 20 out of 100 times 630 is 126. They're the ones she teaches. So that can go in here. Now, so the one she doesn't teach must be the difference between these two. So 630 minus 126, which is 504. Okay, so we've got those totals sorted out. 4/9 of the students she teaches, so 4/9 of these are part-time students. So we want, this is going to be 4/9 of 126. 4 divided by 9 times 126. Okay, we've got a bit of a rounding issue because it's a simple calculator. 55.99999, which we can round to 56. Now we could have avoided that by typing in the 126 first and then multiplying that by 4/9, and we wouldn't have to round it. Okay, but we've got 56 part-time, so full-time must be the difference between these two. So 126 minus 56, which gives us 70. Okay, right, now let's see. Do we need to work out the rest of the information? Miss Patel thinks she teaches 15, so they're only asking about the teaching one, so we don't really need this row here. She thinks she teaches 15 more full-time than part-time. So it's looking at the difference between these two. Well, 70 minus 56 is 14. And we can say, well, 14 is not equal to 15, so is she correct? No, she's not. Okay, so quite a bit for 4 marks there, but all it is turning this, all these words into a couple of numbers, and it's working out which numbers. But if you know, I didn't really, with this one, rather than trying to work out, well, which numbers am I going to need, I kind of started by just saying, well, what can I do? What figures can I work out? And then see, is some of that going to help me? And sometimes that's a good strategy to use, especially if it's not totally obvious where you're trying to get to. Okay, so 3B. 3/7 of the college students are in year 13. Write 3/7 using numbers. 3/7. 3C. Ms. Patel organises fundraising activities for the students. Each student chooses an activity. Alex chooses dog walking. On Saturday, he walks 5 dogs, one after the other. It takes 45 minutes to walk each dog, including travel time. How long does the dog walking take Alex in total? Give your answer in hours and minutes. So 5 dogs, each of them is 45 minutes. So 5 times 45 is 225 minutes. They want it in hours and minutes. Well, we can just take off an hour. That leaves 165. So that's 1 hour. Let's take off another 60. That leaves 105. So that's 2 hours we've taken off. Well, let's take off another 60 minutes, another hour. And basically we keep going until we get something that's less than 60 minutes. So we had 1, 2, 3 hours and 45 minutes left over. So 3 hours, 45 minutes. (3D). Some students take part in a sponsored 5-kilometre run. The sponsored run will take place on the playing fields. Ms. Patel draws this plan of the safety barrier for the run. Okay, so all around here. Now if I move this up. She thinks the safety barrier will be over 1 kilometre long. Is Ms. Patel correct? We've got 4 marks for this. So basically we want the perimeter. Okay, so we've got to measure all of it. So we just add up all the distances. Now we've got some distances missing, so we haven't got this one here, which will be the same, and this one here. So let's start with this length. Well, this is going to be the full length, so it's going to be 190 minus this bit here, 75. So if this is 75, the rest is going to be up here. So 190 minus 75 is 115 metres. So as I said, over here, it's also going to be 115 metres. Now this bit in the middle, well, we know the full length is 250. So we're going to have our 250. And then we want to subtract 65 and another 65. Okay. So you could take one off at a time. You could do 250 minus 65 and then minus another 65. Or you could say, well, 65 plus 65 is 130 and then do 250 minus 130. Either way, you're going to get 120 metres. So for that perimeter, we need to add them all up. So if we're starting here, I'm actually going to list out all the measurements. So we would have our 65 metres, then 115 metres, then 120 metres, then we're going up another 115 metres, then across 65, down 190, along 250, and then back up 190 metres to finish. So let's see. Let's move this up. Here you go. 65 plus 115 plus 120 plus another 115 plus 65 plus 190 plus 250 plus 190, and we get 1,110 metres. Now, to show that we're comparing it, we can't just say, oh yes, that's longer than that. We have to convert this into the same units. So we have to say, well, 1 kilometre is 1,000 metres. She thinks the barrier will be over 1,000 metres. Is Ms. Patel correct? Yes, she is. (3E). These are the times in minutes taken by the students to complete the run. So one took 28 minutes, one took 25, and so on. Use this data to complete the grouped frequency table. Okay, so basically what we've got to do is count how many students are in each category. So you could do it as a tally chart and go through one number at a time. I prefer to say, well, let's find how many are between 20 and 29. So 1, 2, 3, 4, 5. That's 5. And I'm crossing them off, so if I do miss any, I can always add them back on after. 30 to 39. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Between 14 and 49. 1, 2, 3, 4. And between 50 and 59. 1, and that should be all of them used up. And they want the total as well, so we can do 5 plus 14 plus 4 plus 1 gives us 24. Or we could have said, well, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 4 times 6 is also 24. So 3F. The sponsored run raised 3/8 of the total amount of money that was collected. The cake sale raised 36% of the total amount of money that was collected. Ms. Patel thinks that the sponsored run raised 2% more than the cake sale. Is she correct? Show how you decide. Right, so we want to be able to compare them. So what we can do is turn the 3/8 into a percentage. So 3 divided by 8 times 100, and we get 37.5%. Well, let's work out how much more it is. 37.5 minus 36. Well, that's 1.5% more. And that is not equal to 2%. So is she correct? No, she's not. Activity 4, the circus. 4A, Ricardo manages a circus. Ricardo has this data for the number of tickets sold for each of the first 5 shows. So 340 on Monday, 320 on Tuesday, and carries on. What is the range of the number of tickets sold? Well, the range is the biggest minus the smallest, or the difference between those. The highest number is 360. Smallest is 260. So we want 360 minus 260. You might not need your calculator for this one, but we can do it anyway. Always good to check. Get a range of 100. 4B. Each child at the show gets a clown keyring as they leave. Oh, nice. The keyrings are in a basket which contains 60 red keyrings, 30 blue keyrings, and 10 green keyrings. Rafa is the first child to pick a keyring from the basket. He picks a keyring at random. What is the probability that Rafa picks a blue keyring? Okay, well, how many have we got in total? Because that's going to be our denominator. So 60 plus 30 plus 10. So we've got 100. So our probability is going to be out of 100. We want a blue keyring. Well, we've got 30 of them. So it's just going to be 30 out of 100. If you want to write 3/10, that's fine, but it doesn't say you need to simplify it, so you could leave it as 30 over 100 if you want. Ricardo has this data for the number of tickets sold for each of the first 5 shows. So this is the same information we had before. Draw a bar chart to display this data. Okay, so circus tickets, we've got our title. We've got a number of tickets going up the side and days along the bottom. Now this is a bar chart. So we've got 5 days, so we've got 1, 2, 3, 4, 5 bars, that's fine. So this can be our Monday, Tuesday, Wednesday, Thursday, and Friday. Now the values. So the biggest value we've got is 360. So we want to make sure it goes up to at least that. So maybe you can make each of these big boxes 100. 1, 2, 3, 400 would be up there. You want to write your scale so it goes at least as high as your biggest value. So I'm going above it because I'm doing it in hundreds. You don't need to write all the values on. Go up in a sensible jumps. You could put 50s in if you wanted to. Now we've got to mark the tops of the bars. So for Monday there were 340. So here's 300. Here's 400. We've got 10 boxes, so each of these is going to be worth 10. So 310, 320, 330, 340. Now you don't have to have your bars going all the way across, but I am because I think that's easier. It saves time. For Tuesday, we want 320. So 300 was here. This is our Tuesday. 310, 320. And then for Wednesday, we've got 260. So here's 200. 10, 20, 30, 40, 50, 60. For Thursday, we've got 300. So that one's nice and straightforward. Thursday, 300. And then Friday, we've got 360. So 350 is in the middle there. So 360 is going to be one box up. And then I'll draw my vertical lines in. There we go. We've got our label. They'd already put the labels on. If they hadn't, you'd need to add them yourself. But we put these on here. Everything done. 4D. The maximum number of tickets that can be sold each week is 1,800. Last week, the ratio of adult tickets sold to child tickets sold was 2 to 3. The number of child tickets sold was 960. Ricardo thinks that there were 240 unsold tickets last week. Is he correct? Okay, so we've got a ratio here of adult to child tickets. So let's draw a little ratio table. So we've got adult, child, so we're going to have a total. And we've got 2 adult tickets sold for every 3 child tickets sold. 2 plus 3 is 5. So if that's all we had, 2 adults and 3 child tickets, we'd have 5 in total. We're told that the number of child tickets sold was 960. So we're going to work out how can we get from the 3 up to 960 so that we can find these missing values here. So we do the opposite. We do 960 divided by 3, which gives us 320. So we're multiplying that first row by 320 to get the new row. So if we do that, we can do it on both of them. So 320 times 2 is 640. And we can either multiply the 5 by 320, or we can add these two together. We get 1,600. Okay, now they're saying he thinks there were 240 unsold tickets. Well, if there's a maximum of 1,800, and we know that they sold 1,600, well, if we take one away from the other, we know that there were 200 unsold, which is not equal to 240. So is he correct? No, he's not. (4E). Ricardo wants to take out a loan to expand the circus. To find out the total repayment amount, Ricardo needs to work out £25,000 plus 0.11 times £25,000. So in other words, this is like an interest amount. Ricardo estimates 0.11 as a fraction and uses this to work out the approximate repayment amount. Use the estimated fraction and Ricardo's method to work out an approximate repayment amount. Okay, so they don't want you to turn this into an actual fraction. If you use 11/100ths, that wouldn't be approximate, that would be exact. So what we're going to say is 0.11, well, that's close to 1/10. Yeah, if you think it would actually be 11/100, so it's close to 10/100, approximately equal to 10/100, which is equal to 1/10. Okay, so the calculation we've got is going to be 25,000 plus 1/10 of 25,000. So let's keep the 25,000 as it is. 1/10 of it, you're just going to cross a zero off. You can do that with your calculator, but we shouldn't need to. But I'm going to do the addition on my calculator now. So 25,000 plus 2,500. And we get a total of, and I need my pound sign, £27,500. Okay. 4F. Ricardo orders a new circus tent. He does this calculation to estimate the area of ground covered by the tent. 32 divided by 2 squared, but look, the brackets around it, so that's this amount is squared, and then times 3. What answer should he get? So we need to do what's in the brackets first. So 32 divided by 2 is 16. So I'm going to do it one step at a time. So I'm just replacing the 32 divided by 2 with the 16. The squared is still there, but I don't need brackets because it's just one number on its own. And then we're multiplying it by 3. But it's the 16 that is squared. And remember, squared means multiplied by itself. So 16 times 16 is 256. We still need to then multiply that by 3. And if we do that, we get 768. And they want the area of the ground covered. They haven't said whether it's meters, centimetres or what, so I'm just going to leave it as 768. And finally, 4G. The tent is put up in a rectangular field. The field measures 60 metres by 65 metres. Calculate the area of the field. Okay, it's rectangular. 60 metres by 65 metres. Well, the area of a rectangle is the length times the width. So 65 times 60. Nice way to finish the paper. And we get 3,900 metres squared. Really good example of why it's important to go all the way through the paper. This is different to a GCSE paper where the questions tend to get harder as you go along. Functional skills, we're ending on a nice straightforward question here, so make sure you give yourself enough time to look through all of the questions in the paper. I hope you found that helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I upload more videos, and I look forward to seeing you again soon. Thank you.